Hello, everyone. Thanks for joining this presentation. So thanks, Andrea, for setting up everything. Today's talk about the groundwater research in Florida. And in this presentation today, I would like to give you an update about our findings and results for this study so far. Before I start, I would like to acknowledge the work of my PhD student, Sayed Biazar, who is working on this research as part of his PhD program. I'm gonna have like a brief introduction, and then I just explain the objectives of this research. What is the groundwater modeling work, the development of our model here in Florida, and the calibration and validation results of our modeling and scenarios that we have developed so far, the alternative solutions, which could be looked at as alternative solutions, and the future work of the project. So we talk about the importance of groundwater here in Florida. So, and one reason it makes it vital and super important here is like how one reason behind it is that the way we depend on it. Florida's groundwater, it supplies more than 60% of the total fresh water used in Florida. So when we look at this number, in average in the United States, this number is 20%. So, and besides that, more than 90% of drinking water for Floridians, it comes from groundwater. So it can be said that here we rely on this natural resource more than any other place in the United States. So if I want to name some features of the Floridan aquifer, and we call it Floridan aquifer, which is the most, actually the largest and one of the old ones in the world, this aquifer is. So if I want to name some important features of the groundwater system in Florida, I can start with its karstic topography. And the karst topography, we usually use it to describe geological formation which caused by dissolving of soluble rocks. So the karst topography itself is just usually characterized by sinkholes, which can be appeared at the Earth's surface, and underground caves. So both of them, we observe a vast majority, like a network of them, such as springs, caves, and sinkholes, especially in northern Florida. So because of this feature, we could say that groundwater is the main source for the water, and surface water is related to it. But those are not the only features that I want to just highlight. Besides that, it's unique. The Florida's aquifer unique because of its geographical and climate characteristics. The sea level fluctuation, for example, here, the heavy rainfalls that we have in Florida, which is unique, the sandy soils. So all of them, it makes that Florida's surface water depend on groundwater contributions. One example I can say, for example, in many areas, surface water flows into groundwater through the sinkholes or reversing springs. And spring-fed streams, those are another examples, like which can depend almost entirely based on the groundwater. If like those springs are the source for a ditch or a stream, and sometimes it's very huge. And like the lakes and canals and rivers also here, they receive over half of their total inflows from groundwater. So knowing that they are very related to each other, so in terms of groundwater issue, we can say if there is an issue in the groundwater, we are going to have issue in surface water, most probably. Some groundwater issues I want to point here are like groundwater depletion, which is something specifically in many areas, like in Florida, specifically like the coastal area and some areas in the northern Florida. In general, we can say 3.5, for example, like if I want to give a number, I think it's 3.5 cubic kilometer of groundwater removed from the storage of Floridan aquifer during the long term, like a century or so. Saline-related contamination issue, that's another problem. And public supply wells have become salinized in many areas, and it has been observed in coastal areas of Florida, close to South Carolina. And the nutrient pollution, that's another issue that we face here in Florida groundwater system. And it comes from things like septic tanks, municipal wastewaters, sanitary landfills, agriculture or nutrient fertilizers, and many other things. But in general, the nitrogen, in terms of in form of nitrate, it's the most widespread non-point source pollution in Florida. And there are many impacts of nutrient pollution, which like I can name as like some of them. If I want to name some of them, I can say like the nitrate contamination in groundwater, it ends up having eutrophication in the surface water, specifically here that groundwater and surface water is very related, and when that happens, it's like it comes with a risk to human health. So, but how to prevent this and how to control the nutrients in the groundwater? There are many ways, and to some extent, additional regulatory measures can help to control nutrients, but obviously it's not like enough in all places, all locations, and things like waste management practices and low impact development in rural and urban areas, those could help to control the nutrients. So knowing all of this, now I want to say like what's the goal and the objective of our groundwater study here at ONA. We would like to provide a tool for simulating groundwater system, evaluating the effectiveness of different scenarios, what we have currently on the landscape and what we can propose for future in terms of waste management practices to improve the water quality. So to reach that goal, like we can look at different specific goals, like a numerical model, which can help to which is like one important step to develop that tool that we have talked about in the main goal. So we can develop, we are developing a numerical model which could simulate the groundwater system and predict how the system can be affected by changes that happen during the years. And then proposing alternative scenarios, which we're already working on it. And finally, prioritizing the waste management practices to enhance water quality. Let's look at our groundwater model study schematically. We have started with like any other study, we need to do background review and data management. We have collected the data. We are setting a monitoring network here in some selected sites in the central Florida. We have started in ONA developing a monitoring network systematically, and we have some actually good monitoring network area in the Harney Pond Canal area. We also started having our monitoring instrumentation to be installed and studied in the Lookout Reserve. So, and then data analysis the data analysis, since we have already data for some areas in Central Florida, we have finished the data analysis for them, and we have developed our first model in Central Florida in the area of Harney Pond Canal. So the model development, there are some key tasks that it has been taken, such as conceptual modeling development and numerical modeling development. We have developed both of them. We have the results of model verified and successfully calibrated and being able to simulate the existing condition that we have there. And then using that model, which has been verified and could be representative of the existing condition, we have developed different scenarios based on, currently we only work at fertilizer management scenarios and irrigation management, but hopefully we are going to have more scenarios when we extend our model and when we have collected more data. And then using decision-making tools, which are like advanced modeling techniques in management, we could develop a criteria or an approach to see which best management practices could help, which combination actually, not only which. So this is where we are in our program in terms of groundwater modeling study. We are working on prioritization of the practices. But there are some interesting future studies that we could develop using this existing verified numerical tool. Such as, for example, we can use the results or this model, which has been verified for the areas of the Central Florida, to look at the climate change impact assessments. And that's possible with using the global models of climate and downscaling them, using different methods of mathematical or statistical methods to downscale the scenarios and having them prepared for the area of Florida. And then using this model, we could see the impact of different practices in future. So another thing, for example, the interaction of the surface water and groundwater in different areas, it's another topic that could be developed or could be studied by using this method. The same as like the vulnerability of the groundwater to the flood. For just as an example, for example, like when the hurricane happened, we had a lot of huge amount of water on the ground, which definitely has different water quality than the normal rainwater. So we could look at, using this model, we could look at the impact of that amount of water to the system and the impact of them on water quality in different areas. So this was like a summary of what we want to do, what we have done so far. One focus of this program, as I explained, is studying local groundwater resources to manage and develop the water supply efficiently. So this study has been conducted to evaluate the hydrogeology and groundwater quality in the area that you could see here in this picture. You could see two areas. One is the smaller one is called a site model. Basically, we have developed two models, the site model, and the bigger one is the regional scale model. The site scale model is selected and limited to Buck Island Ranch based on the availability of data, which is the 4,200 hectare, and it's located in Highland County, and is approximately the same distance from the Lake Stopoga, the Lake Placid, and the Lake Okeechobee. So, but this regional scale model is being developed by extending the areas of the smaller model to the natural water system, as you see in the north and northwest and southeast, it's like limited to the Lake Stokova and the Lake Okeechobee, and in the other areas like the canals and the rivers are the boundary of this modeling. So this two-scale modeling approach is a common approach of numerically model groundwater system, and there are like advantages that we take like from we get from this approach. One of them is, for example, we could address adverse boundary condition impacts if like we have, because the model is limited to the natural water, and usually the natural water elevation is somehow constant. And also, it's like easier in future to extend the site scale model or the regional scale model to consider the other areas after we get the data. And we are going to have eventually a larger area of the aquifer of Florida to be covered with the model. So, step here in groundwater modeling work is to develop the conceptual model. The conceptual modeling actually framework, it reflects the fundamental hydrogeological concept of the area with respect to objective that we would like to study, which here is the water quality. So the purpose of this study was to evaluate the impact of nitrate on groundwater, and also to see the nitrate leaching and lower aquifer analysis in terms of nitrogen. So there are three layers in Florida groundwater system. The first one is the superficial aquifer system, which is the shallow aquifer. And the second one is the intermediate aquifer, which consists of some intermediate confining units, and finally the Floridan aquifer system. So since here we have like we have studied here the superficial aquifer system, which is the superficial aquifer, and the reason is that based on the literature review and previous studies and everything we got from different organizations, fortunately, the Floridan aquifer system has not been faced like issues like related to nitrogen, but it has been observed in superficial aquifer. So that's why we decided at the first step to study the superficial aquifer in Central Florida. So in order to develop the model, like we need certain, like many inputs data, but some of the important ones that I can name here are topographic data, boundary condition data, initial heads, and inflow, outflow data. But everything is quite obvious what are those, except the inflow and outflow. When we look at the groundwater system, the model inflow are basically we can say is the water gets into the system, such as like the general head boundary we have selected here in this study, such as the lakes and rivers, the recharge including the rainfall, irrigation return flow, and the model outflow is whatever flow or water getting out of the system of the hydrogeologic unit or the aquifer system. So, like general head boundaries, again, we have it like we have considered the natural water system, the well pumping, evaporation, drains, or like through the ditches, or if any drainages exist. Those are the model outflow. So, using those information, we have developed our model. And we have calibrated the model, validated the model for different states. One for a steady state model. Here, it means that for 1 year, we have looked at the water level, and we assume that the model is actually in the steady state, the state is constant, and then transient model, we have looked at the model results, and as you can see, like we have selected 6 different wells, observation wells, and the results showed that our model was able to simulate the observations pretty well. So then we have looked at the water quality. For that purpose, we had the data in the area of Buck Island Ranch in different wells. The water quality has been measured for many years for long term, but we have looked at the year 2019 to 2021 for 3 years for verification of our water quality, and you see the observed and calibrated value, verified values of nitrate are presented here. So by knowing this, we could say that this model is can be used as a base model for this area, and the model is well calibrated. Then we wanted to look at different scenarios. So in order to develop the scenarios, we have looked at, as I mentioned in the beginning, we have looked at in the fertilizer and irrigation at this stage. So it means that, like the figures that you could see here, the first one on the top, it shows how the ranch has been irrigated using the pumps and back pumping and pumps, and like using the structures which are available in the ranch. So those are the areas under irrigation normally in different months of the year. And the second figure on the one that you can see in red or orange color, those are the pastures which have been fertilized or is being fertilized under current situation. So it means that the fertilization are applied only to those pastures here. So what we decided to do, we have developed more than 20 scenarios, like to look at every possible combination or study the impacts of those on water quality and of course the water level. But here I selected few of those scenarios just to explain it here and look at the results together. The first 3 scenarios that we have selected is related to the fertilizer timing. As you can see, the first one, we have applied every pasture that you can see highlighted here in red from the months 1 to 9, we have had fertilizer, and we kept the irrigation the same as the current. So, and this is the worst case scenario for us. And number 2 was we have decided to change the months of fertilizer application and keep the irrigation the same as it is. And the third one, we have for the second one, as you see, it's mostly during the dry months of the year. And the number 3 is we applied fertilizer during the wet season, and we didn't change anything regarding the irrigation. And then we decided to those 3 scenarios was timing of fertilizer, and then we decided to change the rate of fertilizer by reducing 20% and 50% to see what's the impact. And the group 3, or another set of fertilizer, a set of scenarios has been developed to see the impact of irrigation generally. We have reduced the irrigation, we have changed the timing of irrigation. We have played with irrigation in those scenarios from scenario 6 to 10 to see the impact of irrigation as well. So for the first one, for the first 3 scenarios, which was the timing of fertilizer application, we want to look at the results. If you look at the results, we could see if the worst case scenario, we have the highest nitrate amount. And then if we do it for the dry season, which is the black one or gray one, it's going to be reduced, like the amount of nitrogen reduced a lot compared to the worst case scenario. And then during the wet season only, although we have like from 10 months or 9 months, we have reduced it only to 3 months application, but still you could see the amount of like the nitrogen in the system has not been changed that much. So it means that the dry season during the months of 3 to 5, if we apply the fertilizer, we are going to have reduction in groundwater nitrogen, and that's something like kind of the results that we have expected actually. So, but the thing is, it showed us the model is able to simulate it. So if we look at in this set of scenarios, we are looking at the rate of fertilizer application. So it's like, that's why we compare scenario 2, because we just noticed that scenario 2, which is the fertilizer during the dry period, is the best so far. So we keep that one, and also we are going to look at the reduction of the fertilizer. So let's see what's the impact of rate of fertilizer, and this is exactly what we expected again. Like the scenario 2 is the application during the dry period. Then we have the 20% and then 50% reduction in amount of fertilizer, and this is what we got. The third thing that I'm gonna share with you regarding the scenarios and their impact on water quality is about irrigation management. So we want to see what's the impact of irrigation this time on water quality, on nitrogen actually. So here we select scenario 2 again because like we found this one better than like the wet period, and then 20% reduction in irrigation, and then no irrigation on this scenario, and 30% reduction. So these are the 4 scenarios that we have considered here and the model for, and we found that the irrigation does not have much impact on water quality. So it could be due to different reasons, but mainly like it could be further studied, but mainly in Florida, because the amount of irrigation, like in this ranch, for example, like compared to the amount of rainfall is negligible. So maybe that's the reason. So there are, like, this is something that we have to look at different areas and see the impact of irrigation, how important it is in different sites, different watersheds and aquifers, areas of the aquifer. What we are doing, we started to do, and we are going to do in a very close future, is to develop more scenarios, and based on the information that we get, like we are working on this information to compare and see how important are different scenarios, how much is the acceptability of them by having the you know, like comparing them together, and then based on information that we are going to get from this survey from stakeholders and from agents and experts, then we could develop a model like indices, like different indices, like environmental index, like which is water quality thing, economic index, and social acceptability of the scenarios as an index, and then using the AHP method or the management model called decision-making model called MCDM, and using also the soil and water assessment tool, which we are working to develop it for the same area in order to see in order to prioritize the practices that we are developing here in Central Florida. That is the future work and the work that we are, the part of the work research that we are currently working on it. So this was what I wanted to share with you today in this presentation. Thank you very much for your attention, and let me know if you have any questions.
Golmar, while we give a moment for those online to enter a question if they would like, I'm going to take a moment to share a few upcoming announcements.
Sure.
So everybody, if you would, please mark your calendar for August the 15th. That is our next Ona Highlight, and that's going to be a special that we do each year with the Florida Cattlemen's Association, with the president, Pat Durden, speaking, and he's going to be sharing about the Cattlemen's Association history. He's going to be sharing about its structure and providing some information on things that they are doing in regard to federal and state legislation. Another event that's coming up in the fall that is not something that we necessarily are hosting, it is being put on by the Citrus Research and Education Center, is a citrus pest management course. And as I always do, whenever I send you guys the recording, I will include the flyers for these events. The next one is going to be quite a ways off. It's not until February 3rd of 2024, and that is the Progressive Agriculture Safety Day. This is being hosted by Sarasota County Extension as well as Farm Bureau, I believe. So they did one last year and it was a great success. And so if you have kids, I recommend that you save that date and share it with those that you know that would like to attend. If you're not already doing so, we invite you to follow us on social media. We're on Facebook, Twitter, and YouTube. And also check out our website for some very helpful information. And if you do not get our weekly news email blast every Friday, just send me an email and I will get you signed up so you don't miss anything. Okay, Golmar, we have two questions. One says, does your modeling take into account soil types in areas that may have perched water tables?
Yeah, it does. It does include the soil type in terms of perched water table. We have looked at different observations that we have, like for long term. But if there was any, of course, we could include it, but not for this specific one because we couldn't find based on our record.
Okay, and question 2 asks, well, they state, great presentation, Golmar. Do you have an existing or future groundwater quality data to calibrate your models? Sorry if you already discussed this already.
Sure. Yeah. Yes, we do have groundwater quality in terms of nitrogen, and that's what we have used to verify our model. Yes.
Okay, that does it for the questions. Would you like to say anything in closing, Golmar?
Thank you everyone for your attention, and yeah, that's it. Thanks, Andrea.
Okay, you're welcome. Thank you for joining us today. And thank you to everybody online with us. We greatly appreciate you taking time out of your day to be with us, and we look forward to seeing you August 15th.